We've really drastically changed the way our catchments operate through land clearing, vegetation change, urbanisation. So our catchments no longer behave in the way that they used to be. And in a changing climate, the sort of extreme weather events are really exposing that our catchments are no longer resilient to those events.
A healthy catchment is a catchment with clean air, clean water and healthy forests. When we have degraded catchments, you run into serious issues. It costs us a lot more to treat our drinking water to a drinking standard. It costs a lot more to produce our food due to contaminated land or loss of productive soil. Degraded catchments also require restoration, which can be prohibitively expensive. It could be as simple as planting some trees in a riparian zone, or as costly as retrofitting stormwater treatment devices in our cities.
In practice-based industry at the moment, there's definitely a gap both with scientists and engineers. Scientists having the understanding of the problem and diagnosing it, but then not quite understanding how that fits into the jigsaw of getting things onto the ground and delivered. And on the flip side, with engineering going in and solving a problem but not having an idea of the theory or the actual science behind the issue.
There's a need to understand more about catchments, and that's what the focus of the Master of Catchment Science is really about.
Having a degree in catchment science is really important, especially if there's a fairly strong industry component. The relationship of academia to industry is a really important one and builds on the knowledge that is gained in fundamental understanding with the practical application of what it means to apply that knowledge in the real world.
Master of Catchment Science really aims to bring together a whole range of disciplines that are necessary to understand about catchments. So we need to understand the relationship between rainfall and runoffs. We have to understand some of the hydrology. We need to understand how water moves across the landscape, so the geomorphology and how it interacts with the landscape and causes erosion. We need to have some understanding of biogeochemistry, the way in which the chemicals in the water, particularly nutrients, are trapped and transformed as they move. And we need to understand something about the freshwater ecology, how these systems operate as ecosystems. So the Catchment Master's degree is really aimed at bringing all of those biophysical disciplines together. If we want to fix catchments, we also need to understand something about the economics of this as well. We need to understand what the costs and the benefits are of good catchment management. That range of skills is not currently taught in any degree program. And the Master of Catchment Science is really aimed at producing a generation of water professionals who actually understand that mix of biophysical processes.
The benefits I see of IWC, or the International WaterCentre, leading this degree is that they're exposed to a wide range of catchment issues across the world, not just the Australian focus. So it will really bring that real world into the degree.
It's important to combine engineering disciplines and true science disciplines to gain effective catchment restoration solutions. If we treat one in isolation, you only get a snippet of the real solution.
As an engineer, having an appreciation and a respect for the science will definitely change the way you look at the world, for one, and then secondly, how you solve problems on the ground.
In a changing climate, as the frequency and intensity of heavy rain events comes, as our catchments become more and more degraded from changing land use, there's going to be an increasing need for a new generation of water professionals, and the graduates from the Masters in Catchment Science are going to be the next generation that can solve a lot of these problems.